Romex wiring can be installed inside of Conduit for outdoor service changes to feed existing branch circuits. However, it is crucial to understand and apply derating factors to the Romex wire when it is placed within the conduit. Derating reduces the allowable ampacity of the wire, taking into account the number of current carrying conductors within the conduit and the ambient temperature to which the conduit is exposed. Let's delve into the specific aspects of using Romex and conduit and the appropriate derating procedures. Firstly, it is important to recognize what Romex, or NMB cable, is designed for. Romex is typically used for interior wiring in dry locations. It's constructed with 2 or more insulated conductors and a ground wire wrapped in a non-metallic sheath. When used in conduit outdoors, the conduit provides physical protection against damage from the elements such as sunlight and moisture. Secondly, while conduit offers protection, it also creates a confined space that can trap heat. Heat is the enemy of electrical insulation, and excessive heat can degrade the insulation of Romex, leading to premature failure and potentially dangerous conditions. This is where derating comes into play. Derating refers to reducing the maximum current a wire can safely carry. The National Electrical Code, or NEC, provides tables that outline derating factors based on the number of current carrying conductors in a conduit and the ambient temperature. Now, let's consider the specific NEC articles and tables that are relevant to derating. NEC Article 310.15 addresses ampacity and temperature correction. This article is the primary reference for determining the allowable ampacity of conductors. The ampacity of a conductor is the maximum current, in amps, that it can carry continuously under specific conditions of use without exceeding its temperature rating. NEC Table 310.15 B16 provides the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air and in raceways. This table is a starting point for determining the ampacity of Romex. However, it's essential to recognize that Romex, specifically NMB cable, has a temperature limitation of 90 degrees Celsius for dry locations, but the ampacity must be based on the 60 degrees Celsius column for conductors rated 100 amps or less, or the 75 degrees Celsius column for conductors rated over 100 amps, as per NEC section 334.80. Therefore, when using table 310.15 B16, you must use the appropriate temperature column based on the ampacity of the circuit. NEC section 310.15 B3 covers adjustment factors for more than 3 current carrying conductors in a raceway or cable. When multiple conductors are bundled together in a conduit, the heat generated by each conductor can raise the overall temperature within the conduit. This necessitates a reduction in the allowable ampacity of each conductor. The adjustment factors in Table 310.15 B3 I provide the percentage of ampacity reduction based on the number of current carrying conductors. For example, if you have 4 to 6 current carrying conductors in a conduit, the ampacity must be derated to 80% of its original value. If you have 7 to 9 current carrying conductors, the ampacity must be derated to 70%. NEC section 310.15 B2 addresses ambient temperature correction factors. The allowable ampacities in table 310.15 B16 are based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature exceeds 30 degrees Celsius, a correction factor must be applied to reduce the allowable ampacity. The correction factors are provided in table 310.15 B2 and vary based on the conductor's temperature rating. For example, if you are using Romex with the 90 degrees Celsius insulation rating and the ambient temperature is 40 degrees Celsius, the correction factor would be less than 1.0, resulting in a lower allowable ampacity. Here's an example of how to apply the derating rules. Suppose you have a 20 amp circuit using 12 American wire gauge, or AUG, Romex, which is rated for 20 amps at 60 degrees Celsius according to NEC table 310.15 B16. and you are running it in a conduit outdoors with 5 other current-carrying conductors. Firstly, determine the base ampacity of the 12 AWG Romex, which is 20 amps. Secondly, determine the number of current-carrying conductors in the conduit. In this case, you have 6 conductors. Thirdly, refer to NEC table 310.15. B3. As to find the adjustment factor for 6 current-carrying conductors. The adjustment factor is 80%. Fourthly, multiply the base ampacity by the adjustment factor. In this case, 20 amps multiplied by 0.8 equals 16 amps. Therefore, the derated ampacity of the 12 AWG Romex in this scenario is 16 amps. This means you cannot load the circuit to its full 20 amp capacity. You must limit the load to 16 amps or less to ensure that the wire does not overheat. In addition to derating for the number of conductors, you must also consider the ambient temperature. If the ambient temperature exceeds 30 degrees Celsius, you must apply a temperature correction factor. For example, if the ambient temperature is 40 degrees Celsius, you would need to consult NEC table 310.15. B2 to find the appropriate correction factor for the conductor's insulation type. Multiply the derated ampacity by the correction factor to obtain the final allowable ampacity. It's important to note that the NEC provides specific requirements for the type of conduit that can be used outdoors. Typically, rigid metal conduit, intermediate metal conduit, or rigid polyvinyl chloride or PVC conduit are used for outdoor applications. The conduit must be properly installed and supported to prevent damage and ensure that it remains watertight. Also, when running Romex in conduit, it's crucial to ensure that the conduit is adequately sized to accommodate the wires. NEC Chapter 9 contains tables that specify the maximum number of conductors allowed in different sizes of conduit. Overfilling a conduit can make it difficult to pull the wires and can also impede heat dissipation, further increasing the risk of overheating. Moreover, when connecting Romex to devices or equipment, you must use appropriate connectors and fittings that are rated for the specific application. For example, when connecting Romex to a junction box, you should use cable clamps to secure the cable and prevent it from being pulled out. When connecting Romex to a circuit breaker or receptacle, you should use terminals that are designed for use with solid or stranded wire as appropriate. Remember that using Romex in conduit outdoors is generally acceptable, but it's critical to follow all applicable codes and standards to ensure a safe and reliable installation. Always consult the latest edition of the NEC and any local amendments to ensure compliance. It's also advisable to consult with a qualified electrical inspector to review your plans and ensure that your installation meets all requirements. Additionally, consider the type of environment a conduit will be exposed to. If the conduit is in a location where it may be subject to physical damage, such as being struck by vehicles or equipment, you should use a more robust type of conduit, such as rigid metal conduit. If the conduit is in a corrosive environment, such as near saltwater, you should use a corrosion-resistant type of conduit, such as PVC-coated rigid metal conduit. Furthermore, think about the long-term maintenance of the installation. Ensure that the conduit is accessible for future repairs or modifications. Avoid running conduit in locations where it may be difficult to reach or where it may be subject to damage during routine maintenance activities. Also, consider the impact of the installation on the surrounding environment. Avoid running conduit in locations where it may interfere with landscaping, drainage, or other utilities. If necessary, coordinate with other trades to ensure that the installation is properly integrated with the overall project. Finally, remember that electrical work can be dangerous, and it's always best to err on the side of caution. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. A qualified electrician has the knowledge, skills, and experience to perform the work safely and in accordance with all applicable codes and standards. In summary, using Romex in conduit outdoors is permissible, but requires careful attention to derating and other code requirements. By following these guidelines, you can ensure a safe and reliable electrical installation. Always prioritize safety and consult with qualified professionals when in doubt. Firstly, always consult local codes and regulations for specific requirements. Secondly, ensure proper conduit selection and installation for the environment. Thirdly, accurately calculate derating factors based on conductor count and temperature.